Hello friends. So today's problem of the day from the Leetcode is uh, maximum value of k coins from piles. It's a bit harder problem as I mentioned. So what actually we have to do is that we had been given a set of piles, right? So for example, in this example, we have given two piles and we have been given a number like k. This is the number of coins that I can collect, and we can collect only from the top, just like think like more like the stack. So you can access top of the stack, right? So for example, if I have to pick two coins, I can pick either two coins from the left column, so it is 1 and 100, so max value I can make is 101, or I can pick the second two coin. Basically I can pick the two coins from the second stack, that is 7 and 8, so value is 15. And then the third option is taking the 1 and 7, and answer is 8, right? Now interesting part here is it's more like an optimization problem. So in that type of case, we have the two options. Either we can go with the greedy approach or we can go with the dynamic programming, right? And the in this case, if I take a look at example, like we just fail in the greedy. So suppose in this case I look at 1 and 7, so I pick the maximum value, which is 7. So I got value of 7. I have, then on the stack I have only 1 and 8, so I pick the another maximum value, which is now 8. So the maximum value of coin that I collected is 15. On the other hand, if I have taken this and this, I could have made 101. So this shows you that the greedy approach will not work here. What else we can do? So in this case, what actually is happening is, so we have been given few set of files. Okay, now I can pick coins from any of the pine. So let's say these indexes are 0, 1, 2 and 3. Let's say that I decided to pick this coin. So let's say my current consideration for is this pile. So I have two options, right? Either I can pick it or don't pick it, right? So if I pick the value, that means that I have taken one coin. So I have, say that value is x, so I have the value of x. Now plus, now I am left with k minus 1 option, that I can lift only k minus 1, and that k minus 1 is now again going to be distributed among these fours. Okay, and if we decide that we are not going to pick it, that means that now the rest of the k option is going to be happening in this particular scenario. Okay, now how you can decide whether you should be picking it or not is depends on the number of coins you can have on that particular coin. So for example, for this particular coin pile, I can pick either k coins or how many coins we have in this, that is the size of pile, right? And that should be the, and we can take the minimum of that. That means that that is a maximum number of coin I can pick it from here. And then we can just go iterate, like take the first coin and then iterate for the next uh, rest of the piles. Then you pick the second one, so now you have the two coins taken, and then you for again you explore rest of the pile, and similarly you keep on doing it. Of course the complexity for this is going to be in more of like a polynomial, because you have the option of picking one of or not. So let's first try to write down the code for this approach. Alright, so if my k is less than or equal to 0, turn 0. Okay, so as we discussed, right, so we are going what we are going to do is from this we will start from this particular stack, which is start value is 0, and then we will go and explore the rest of the uh, piles. That means that once you reach towards the end of the pile you are done. So that means that now I am going to write down a function, recursive function, which I am going to call so maximum value of coins, and here I have extra variable which is integer current index. So in this particular case, what's the base case for this? What is the base case for this function is that if my k is less than or equal to 0, that means that there are no point left to pick, or I have reached to the end of the files. So that means that current idx is greater than or equal to files.count, and then you just return 0. Okay. Uh, Now, as we discussed, let's check how many coins I can pick from this current pile. So, integer coin count is equal to piles of current idx. So this tells you that how many coins I have in this particular pile, and in how many you can pick. It is maximum pick count is equal to math.min of k comma it's not count, it's a coin count. Okay, so now I have that we as discussed we have two options. The first option, option 1, don't pick coin from this pile. Okay, so if I'm not taking this pile, that means that I'm going to go and pick from the next coin. So that means that my next coin would be, next pile would be current index plus 1, and number of coins same because I have not picked any coin from the current pile. Okay, then it returns some value, so let's say integer result, and then the next option is I decided to pick from this pile. Okay, that means that let's say that after picking I have pick sum is equal to 0, and for integer I is equal to 0, how many coins I can pick from here, which is max pick count I, right? And what is the value of the coin? Integer coin value is equal to piles of current idx of I, right? So interesting part here is that every time the value changes, like I is equal to 0, so I pick the top of the pile, then second top, then third top, like this. Okay, and total how many I have picked is pick sum plus equal to coin value. So this is the total coin value that I have picked from the current pile. Now let's go ahead and work on the rest of the files. So I am going to call this function from files, and what is the next index? The next pile will be current idx plus 1, and how many coins are left to pick, which is k was originally, and as I've decided to pick from here, so I is the number of value the coin that I have already picked, right? So it's a k minus I, since but it is 0 base, so it is k minus 1, and this is, let's say how much you have got. Integer temp is equal to this. Okay, and so result would be math.max result comma uh, what how much you have picked from the current file and how many you have got the rest of them, and then you just return the result. Run. Alright, so this works of basic cases. I am sure that we will get hit the TLE in this approach as expected. Okay, now let's see, once we have this recursive solution in place, let's try to come up with a solution that can be used memoization. So in this particular case, uh, if I look at my recursive, so the current index and k, these are the two variables that we have, and if I look at this approach here, that means that I might be evaluating for a given current index and given k multiple times in the whole solution, right? How about if I cache those results and use it? uh, okay, so since we have the two variables in the equation, so that means that I am going to create a two-dimension array that will work as my cache, right? So let's say integer array memo is equal to new integer, and the size is going to be your k comma piles dot count. Okay, so interesting part here which I found was, since piles are based on index, right? So they are going to vary from 0 to count minus 1, so that works fine. But here uh, the minimum value can go is k is equal to 1. That means that k is actually 1 base. So what we need is we will create a size of k plus 1. The other thing that we will do is, now we need to initialize the memoization. Initially by default values are 0. Uh, right, so let's initialize them with a value of minus 1. So that minus 1 will tell us whether we have evaluated any result or not, right? So for integer I is equal to 0, I is less than or equal to k plus plus I, for integer j is equal to 0, j is less than files dot count plus plus j, and memo of I comma j is equal to minus 1. Okay, now we are going to pass this memoization into this function, right? Okay, so let's pass it, and let's do it everywhere to make things faster. Alright, so we are passing. Now let's start using it. So now we have to check whether if my memo of so if you look at the first index is actually represents k, so k comma current index is not equal to minus 1, then I am going to return this value. Alright, and let's set those values here, which is going to be my here. So this the result and give the set value, right? That should be good enough for memoization. And once you submit, hopefully that things works fine. Sounds good, and beats 100% till now.